College of Science, Commerce and Management Studies extend a very warm welcome to all of you. I welcome our resource person for this session, Dr. C.P. Gupta sir. Sir is presently a senior professor in the Department of Finance and Business Economics, University of Delhi, and was the head of department and the Dean Faculty of Commerce and Business, University of Delhi. Sir has provided us with the knowledge on the questionnaire designing yesterday. Today, he is going to take a session on SPSS. SPSS is short for Statistical Package for Social Sciences, and it's used by various kinds of researchers for complex statistical data analysis. Without further ado, I request Sir to take over the session. Sir.
So friends, let's start. I'm sorry, there was some problem somewhere, but I think we'll not find a difficulty here. And I'm happy to see you here. Thanks a lot that you have made it today. So it shows that you are really keen to learn the things. And that's the reason I'm saying that I'm happy to see you here. So in this session, we have to learn and learn, nothing else but to learn. So just a minute. So first learning to begin with is never miss an opportunity to learn. The fact you people have joined this workshop, that shows you are really keen to learn and you don't want to miss any opportunity. Today is your opportunity to build the tomorrow you want. Whatever you are learning, that will build your capability and that you can make use for tomorrow. Grab it, commit to it, and finally see yourself a more experienced, more learned person in the end of the workshop. So give your best for the learning in the session, and your cooperation will be highly appreciated. And don't hesitate in asking questions. Anytime you can stop me, anytime you can put your question, anytime you can raise your hand, and we will love to answer those questions. But make sure that whatever we are doing here, you are learning them and you're not finding any discomfort with whatever we are discussing. Okay, so I said your cooperation will be highly appreciated, and let's start our session with God blessings and with a lot of positive energy. So welcome you to the world of Spss. That's what we are going to do in this particular session. So focus will be on learning Spss, and I will be using certain statistical tool, but I believe that you might be aware of it. If you find any difficulty in that, you can ask me. Otherwise, I will presume that you all understand those statistical concepts, which we are going to do through Spss. Agenda for this is as follows. We have to learn how to prepare data in Spss for further analysis. We have to also learn how to get a feel about the data through descriptive, statistic, graphs, and charts. And we will also learn how to use Spss for testing various hypotheses. Okay, plus anything else you want to use. Mr. Pradhan is raising hands. I don't know. Can the organizers allow Mr. Pradhan to talk because he's raising hand? Okay, so let's get ready for the preparation of the data using Spss. Spss stands for Statistical Package for Social Sciences. Statistical Package for Social Sciences. And it was initially developed in 1965 at Stanford University in California. Then it was registered with a registered trademark by Spss Incorporation, and later on it was bought by IBM. So now IBM owns Spss, and the latest version we have now is 28. When IBM bought it, it renamed as PASW, Predictive Analytics Software, but later on, they were not comfortable with this name, so later on they rename it as IBM Spss. So let's start our session with hints on Spss, but an advice before we go ahead is you have to sit on a computer or a laptop having Spss software. Experiment with it, play with it. Unless and until you do something of your own, you will not be able to master Spss. The best way to learn Spss is confront with Spss, or experiment with Spss and do a lot of exercises on Spss. The best way to get maximum output of Spss is visualize in your mind what is to be done, how it is to be done. Spss run as per your instructions. If your instructions are wrong, results will be wrong. So you have to be clear in your mind what exactly you want. And you should be also clear what is that, through which you can get what you want. And then you tell Spss, do this, and get me the right results. If you're not clear what exactly you want, nobody can help you. So you have to visualize that, yes, this is what we want. So let's get ready for Spss, and when you open the Spss, the very first screen comes, it's like this. If you see at the bottom of it, you will find two windows. One is the data view. Another is the variable view. In data view, you can see your data. You can edit data. You can copy data. You can paste data. I mean, it's like a spreadsheet. So whatever you think you can do in a spreadsheet, all those things you can do in the data view. Okay. And in case of the variable view, you can see the variables which are being defined for your data. So you have the name of the variable, type of the variable, width of the variable, decimal places for the variable, labels, values, missing values, column length, alignment, measurement, and when you give a name to your variable, it should not have any special character. So like at the rate, hash, hyphen, these are the special characters. They're not allowed in the definition of the variable name. Then you can define type. Is it a numerical number? It's a percentage, it's a currency, it's a string, whatever is the type of the variable, you can define it. Width is how many places you need for your variable. So if you say 20, that means you need 20 spaces for your variable. And if you want 2 decimal places, you can specify 2, 3, whatever you want. You can specify your decimal places. Labels. Can any one of you tell me what is the difference between a variable name and labels of variable? Any one of you? Spss understand only the name of the variable. It processes variable by its name. Labels are for us. Labels gives us clarity about the variable. So for example, one of the variable is sales. And label will be clarification about that particular sales. So you can write in label annual sales in rupees crores. So basically it's a description of the variable so that you understand what exactly that variable means to us. So variables like X and Y, yes, Anuprasad, labeling is, I won't say coding, labeling is, the clarification or it's a detailed explanation of the variable. It is shown in charts and graphs. Even Amitabh, the labels can be shown in the tables as well. Okay, values. Suppose you have a value, you have a variable gender. And you have codified 1 as male, 2 as female. So in the value column, you can specify 1 is male and 2 is female, so that you know what is 1, what is 2, you can understand. Suppose you are asking about a statement. We are defining the scale of agreement, strongly agree, neutral, disagree, strongly disagree, and you have given numbers. So you can tell what 1 means, what 2 means, 3 means, 4 means, 5 means, and that you can define in value. And that definition is important because today you remember what 1, 2, 3, 4 means, but after a month, 2 months, when you are coming back and working on your data, you are likely to forget what these numbers are. So it is always advised that you give proper definition to the values which you are using. Okay, if you have a missing value, you can give a code. Say, for example, many times people give a code of triple line to missing variable. So you can say triple line is my missing variable, missing value. Columns will give you the length of the column, which you can see in the data view. Alignment, do you want right alignment, left alignment, central alignment? That. Spss uses 3 kinds of measures: nominal, ordinal, and scale. And you have to define your variable properly, because if you don't define your variable properly, then you may not be able to do some special kind of processing which you require. So you should have a proper definition of the variables which you are using. Okay. This view is used to enter and edit. That's your data view. Any question about the basics of Spss? And we should be very clear in our mind what is nominal, ordinal, interval scale, and the ratio scale. Spss club these two and put under the one heading, that is the scale data. Avneet, I have a question for you. Can you make a histogram for the ordinal data? Yes, Avneet. Can we make histogram for ordinal data?
Sir, she has written, everybody is using the chat box and asking me questions.
We do not know interval. Nidhi is asking, we do not know interval. Okay. Nidhi, just give me a minute. Let me finish this. Anybody, can you make a histogram with ordinal data? No. We cannot make a histogram by using the ordinal data. Yes, Shubham, you're right. And if by mistake you have defined ordinal data as a scale data, then Spss will give you histogram, even though histogram is not defined for the ordinal data. And therefore, you have to be very careful while defining the nature of your data, whether is it nominal, ordinal, or scale data. I don't know, Suman, what do you mean by difference is not known? Suman? Yes, Nidhi, I come back to your question. What is interval scale data? Anybody? In Delhi these days, we have temperature around 43 degrees centigrade. What is this 43 data? Temperature and time is interval scale data. Yes, Savud, you're absolutely right. Because Savud, they are interval scale data because they do not have any absolute zero. No absolute zero. If you say zero temperature, it doesn't mean that it doesn't have heat. Still, there may be some heat. And 0 degree Fahrenheit, 0 degrees centigrade, they're not same. Zeros are not same. But ratio scale is having well-defined zero. If somebody says a student has got 0 marks, everyone will understand 0 means 0, nothing. If you say you have 0 rupee in your pocket, that means no rupee, no money in your pocket. But that you cannot say about time and temperature. And that's why Savud was saying that temperature, time, these are the examples of interval scale data. So about division and multiplication, I will come later on because this is slightly tricky area. I don't want to enter into it. But one thing, 43 degrees centigrade plus 43 degrees centigrade. Can I say it's 86 centigrade? Why I cannot say 86? Why I cannot say 86? Suppose if water is having a temperature of 20 degrees centigrade and I increase its heat by 22 degrees centigrade, can't I say the total heat now will be 40 degrees centigrade? Vivek, I agree with you. It doesn't have absolute zero. I agree with you. But question is, if you have normal temperature of water, 20 degrees centigrade, and you increase its temperature by 22 degrees centigrade, don't you think it will become 42 degrees centigrade? Right. That's why, so I said that I don't want to enter into intricacies of it because that's a different, altogether a different discussion. When you say addition, you can add. That means if you say that you can do addition, that means you can do multiplication. Multiplication is nothing but repetitive addition. The only difficulty is in the interpretation of it, and we have to be careful about it. Anyway, objective of this is to learn basics of editing of data and preparing data. And I've shared a file with the name Attitude of the Parent toward the Education System in India, a case study. So the data is in there's a file with the name of Attitude Towards Education System. So I open up a file, data file. Okay, so this is the data which we have in this particular file. And if you see the variable view, We have the name of the variables. All variables are numeric, different width. These are the labels which we have. These are the values. Like 1 means strongly agree, 2 means agree, 3 is neither agree nor disagree, 4 is disagree, 5 is strongly disagree. And I've taken 9 and 9 as the missing values. And I've defined the measures: ordinal, scale, nominal. Now let's see what we have to do in it. Data is collected and under these different name of the variables which we have, and file name is attitude towards educational system. Suppose we want to select some specific data. Okay, Rashmi, 9 is a missing value. That means, sorry. When you say 9 is a missing variable, sorry, missing value, the Spss will not process it. Okay, what does it mean? Suppose I want to know the frequency distribution of attribute 1. So I go to analyze, descriptive frequencies, attribute 1. "99 is valid, 0 missing." And let me check where we have the missing values. Okay, anyway, I just write 9 here, 9 here, and see what happens. Analyze descriptive frequency attribute 3. Let me check. Now you can see there are 2 missing values. So the moment I declare 9 as missing, Spss will not process it. And why do we have a missing value? Suppose you don't get any response from a respondent related to a particular question. So instead of keeping blank, I put 9, showing that it's a missing value. So Rashmi, I will suggest never keep a cell blank. Can any one of you tell me why I should not keep any cell in my database as blank? Can any one of you tell me why I should not keep a cell blank? Because I really don't know how this software will take it. Will it take it as a 0? Will it take it as a string space? Will it take it as a missing value? How the software is going to process it, I'm not aware of it. So I don't want to take any risk. I don't want to take any panga with the software. So let me, on a safer side, put 9 whenever there's a missing value and declare it as a missing value so that the uncertainty about processing of a blank cell doesn't exist. Okay, Rashmi? Right. So let's go ahead. Okay, selecting some data which we are talking about. It is a challenge of telling a Spss that select only those respondents that are related to female respondents. So you get the data about male, you get the data about the female. I don't want to process my data for the male. I want to process data only for the female. What to do in that case? I hope you understand the problem. If you don't understand the problem clearly, you will find a problem. So I have to select cases which are related to female. So that whatever processing I do only for female respondents and not for male respondents. Okay, let's see how do we select cases on the basis of the gender. But do you see what is it? Any one of you? 1A. If we have defined value labels, then this acts as a toggle key. You can see the number, you can see the description about that particular number. What does it mean? I show you. Click on it, see what you get. I think let me increase the length of the column. 12. I copy it and paste here. Right, do you see this? Female, male, male, female, and strongly agree. If you don't want to see the labels, you can see the values. It acts like a toggle key, like this. Okay, now I have to process the data for female. Female gets a value 2, male gets a value 1. So go to data, select cases. Go to data. In that data, you will see the select cases option. And we are selecting cases on the basis of gender. If that condition is satisfied, what is that if condition? Gender is equal to 2. I'm going to select all those cases where the variable sex is having a value 2, that's female. Continue. Okay. think let me drag it here. It says filter on. It's selecting all the cases which are female. You will not see any data which is male data. Now, whatever processing I do, that will be for female. So suppose I want to make a bar chart graph for the attitude. And this is the chart only for the female candidates. You can make the frequency distribution also. Say for this. So there are 43 valid cases of women. One is missing, and that's their frequency. Whatever you do now will be done only for female. If you want to switch off this filter, you want to select all cases, process is say, go to data, select cases, all the cases. And when you do this, that filter on sign will go away. And now you can have all the categories here. Okay? We have the data about male and female. One option is I don't want to process for male, I want to process for the female. In that case, you have to select case. Okay. Again, we have data for male and female. What I want now is processing should be done separately for male and female, but for both. That means if you're doing some testing for male, it should be different. For male, it should be different, but you should get results for both groups, male as well as female. In that case, what we have to do? We have to split our file according to the male and female, and then you should do the processing. How do we do it? Again, you go to data, split cases, and condition again is if sex is 2. Sorry, I think I've selected wrongly. Select cases, all, data, split file. And I want my output should be organized by the group, and grouping should be done on the basis of gender. I repeat what I'm saying. I need to process my data for male and female separately, but I want both of them. For that, I have to split my file. So I go to data, split file, and I am splitting the file on the basis of gender. And I want to organize my output as per the both. Okay, now, suppose I want to get the frequency distribution of attitude towards now you can see I'm getting data for the male and I'm getting data for the female. Now, whatever further processing you will do, you will find you are getting separate results for male as well as for female. If I want to make a graph, simple bar chart, for example, now you will see you are getting separate chart for the male, separate chart of the female. So when you are analyzing your data, you have to be careful what exactly you want. And many times we have to process data for separately. Suppose you are working with two states, say one state from south, one state from north, and then you want to do the processing for both the states separately, then you have to split the file as per the states. Assume that we want to processing simultaneously male and female respondents, but separately. In that case, we have to split the file between male and female respondents. So it is splitting of the file. So go to data, then split. So hope that this will help you in starting with Spss. What next we have to do is that's our agenda number 2, getting a feeling about data, descriptive statistics, and graphs and charts. So we have to run to catch the next thing. Let's see what is the next thing which you are going to talk about, how to describe and summarize your data. And you can summarize and describe your data by preparing tables and different kind of graphs and charts. Tables, you can have frequency distribution tables. You can have cross tabulation, cross tab. And of course, you have different kind of graphs. You can describe your data through graphical tools, through tabular. Graphical, you can make different kinds of bar charts, line charts, scatter plot, pie charts, and so on. And please understand, you cannot make a histogram for nominal and ordinal data. So you have to be careful about it. You can make multiple lines, boxes, bars, etc. on the basis of nominal and ordinal data, but not on the basis of scale data. You cannot make a bar chart for the scale data. Please understand that. Okay, so you have to be careful regarding the nature of the data when you prepare a suitable graph. How charts help us in understanding distribution of observations. I'm not going to talk about simple charts, but many times we have to understand the underlying behavior of the data by looking at distribution of the observations. And normally we want to check whether my data is normally distributed or not. Can any one of you suggest me what kind of a graph should I prepare to get an idea about normality? Any one of you? Which chart do you think help you to get a feel about normality of the data? Bell. Amitabh, what do you mean by Bell? Shaped graph. Amitabh, we don't have a concept like shaped graph. Mean, median, mode should be equal. That's the characteristic of a normal distribution. But tell me the name of the graph that can help you in understanding whether the mean, median, mode are equal or not.
The probability distribution graph.
No, we don't have a probability here. We have the observations. Amitabh, you are right, bell-shaped graph, but what is the name of that graph? Ajaives are for finding out the mean and median. They don't tell me the distribution. In order to get the idea about the distribution and the nature of the distribution, we prepared two very important graphs, histogram with the normal curve and box plot. Rohit, these are the characteristics of the normal distribution, but we have to make a graph. And to check normality of the data, we look for histogram. And of course, on that you can impose a normal curve. Like this, you have a histogram with a normal curve. And that will give you an idea whether your distribution is a normal distribution or not. And please understand, you cannot make a histogram for normal and ordinal data. Yes, Avud, you're right, histogram. Another is important graph is box plot. You can draw it horizontally, you can draw it vertically, that's your choice. This line is called the median, that's quartile 2. This is quartile 3, this is quartile 1. That's the minimum. And that's what we get. Thanks. And how do we get that minimum? That's Q1 minus 1.5 interquartile range. And interquartile range is Q3 minus Q1. Yes, Amitabh, PP plot and QQ plot can also be drawn in order to get an idea about normality. But they're slightly complicated graphs. Anu Prasad, I don't know what you said, Q3 plus Q1 divided by 2. No. Interquartile range, we are defining range. Please understand, I'm not defining interquartile deviation. I'm defining interquartile range that's equal to Q3 minus Q1. And we believe that all observations should fall within this limits. Any observation which is falling outside these limits, they are outliers. Like this is an outlier, because it's not falling within that particular limit. And in case of tabular form, you can make a frequency distribution for ungrouped or unclassified, or you can group unclassified. And you can also make cross tabulation. So there's a file with the name of file for descriptive and graphs, and let's see how we can make different graphs for it. Just close it. Sachin, Arun, I will definitely share my PPTs with the organizers, and then they can share with you. What is the advantage of a box plot graph? Anybody? I will say it's a very powerful graph. Box plot is a I just close it. Open the file, data file. I don't know what happened. Anyway, I will come back to that. So let's say first I show the data which we have. This is the data which we have. And I want to know whether the maths and computer science graph, whether they are normally distributed or not. So I go to graph, chart builder. Histogram. I select the simple one, drag, score in here, display normal curve. And then you say, okay. Sabut, what kind of a distribution is it? Is it normal? Is it normal? Anybody? It's not normal. If you see the peak they have, the distribution is leptocratic distribution. Yes, Viveka, it's not a normal distribution. Right is skewed. So it's not a normal distribution. You can easily make out the height of the normal distribution and the height of the actual distribution quite different. If I make the box plot for the same graph chart builder, box plot, suppose I want box plot for scores here. Let me make a simple chart. And it shows two outliers. Just a minute. हाँ सुमित नमस्कार नहीं बोल अरे मैं थोड़ी देर में कॉल करूँ तेरे को हाँ बताओ ठीक है So there's some, I don't know what's happening here. Okay, so these are the two outliers. I think. And what is this 30, 26 and 39? These are the observation numbers. These observation numbers are the outliers in my data. If I want to see these observations, so I have to go to the data view. And Control G. Go to case number 39. If you see the 39 student got very large number, 99. So if I delete this, and then draw it again, that outlier is not there. Second observation is 26. So you can go to data view, edit, go to the case number 26. Is also getting 99. I also delete this. Then when you make the graph again, there is no outlier. So if you wish that your data should not have an outlier, you can remove those outlier. Box plot, I tell you, is very, very important, very powerful graph, and tells a lot of things. This is the median value, sorry. This is the median value, which gives me idea about central tendency. This boxes, say, for example, if you have a box like this, if you have a box like this, you can get idea about the variation or the range or the differences among the values of the variable. So it also gives you an idea about variation. Suppose I make two boxes like this. So 3 boxes. And my median line is here. Median line is here. Median line is here. Saud, can you comment on these 3 types of box plots? Can any one of you tell me this is one median, median is here, median is in between. Amitabh, can you try? Viveka, Rashmi, any comment on these boxes? Amrit, you give me a try.
Sure, sir. Sir, I think the third one would be the central value of all the ranges.
तो नॉर्मल से क्या होगा फिर सेंट्रल वैल्यू से क्या होगा Ishrat, there is no outlier because there is no observation outside these boxes. Observations will be having outlier if you get a point somewhere here. If you get a point somewhere here, then you will have a third one shows that it's normal. Yes, Amitabh? That means these three boxes talks about skewness. It talks about skewness. This is normal. What you will say, it's like this. It's like this. So box plot tells you about central tendency, variation, skewness, outliers. In that sense, I say that box plots are more powerful as compared to the other charts. So as a researcher, my advice to all of you is prepare box plot for your data. And you will get a lot of insight about your behavior of the data. Is that okay? Now, let's see how do we make the tables. To make the tables, you have to go to Analyze. And please remember, all statistical processing which you're going to do, that will be available under the option of Analyze. Descriptive statistics, frequency. Okay, so suppose students, gender, students' background, I want their frequency distribution. And it gives you a lot of information, frequency, percent frequency, valid means excluding your missing value. And this is the cumulative percent. Frequency, percent frequency, valid, cumulative percent. What is the purpose of cross tabulation? अमनीत तुम बोलो, तुम्हारे पास राइट है बोलने का. क्रॉस टेबुलेशन का क्या पर्पस होता है? What is the purpose of cross tabulation? Any one of you?
So to reference more than two tables?
It refers to two variables in the same table. Refer two variables in the same table. And it helps you in getting an idea about the relation between these two. Do you think there is a relationship between the student gender and the student background? I want to know from which background we have more male students and we have more female students, boy students or the girl students. I want to see that association between the gender of the students and the background of the students. Yes, Amitabh, you're absolutely right. Shows relationship between the variables. So for that, you go to Analyze, Descriptive Statistics. In Descriptive Statistics, you will see the option which is cross-tab. In row, suppose I put background, column gender, any comment? Yes, Savud, you're right. Explain subgroups also. If you want result in terms of percentage, but I tell you something very important here for the active users of Spss. What is this symbol? What is it? Any one of you? It's a recall dialog box. In this box, you will see all your past commands which you have done. Whatever you have done in the past, you will get the list of all those commands here. So you not recently used, yes, Savud, you're right, recently used commands. So no need to go to analyze and do the same thing again and again. You can recall from here the command which you have run so far. So I recall from here, cross tab. Suppose I want row-wise percentage, say column-wise percentage. You can get for both. Out of 100 boys, 19 boys are in commerce and economics, while 42% are girls. So that means commerce and economics, girls are going more for economics. And in other courses, we will find the boys are more as compared to girls. Engineering, technology, computer science, by and large, we get the same number of students. Any one of you tell me what is the measure of association? How do we know association? Whether the association between two variables is significant or not. How do I know it? Rashmi is saying correlation. Rashmi, can you calculate correlation between the student's background and gender of the students? These are nominal numbers. Viveka said no. Yes. This, yes. I mean, Savud Nidhi, why do you say yes? Savud, the point biserial is a different thing, but let's look at this table. Most widely used measure of association is chi-square. Chi-square is some measurement that uses association. Biserial point, that's a different thing. I'm not going into it because we don't have the time, but chi-square you can easily calculate. So when you go to cross tab, there is option of statistic. There you can click on chi-square. Chi-square is not coming to be significant. And therefore, no relation, no association we find between the background of the student and the gender of the student. Whatever we see, that's by chance, but not by design. So you can make cross tabulation and अवनीत साबुत को अनम्यूट करो जरा.
Yes, sir.
Hello, good afternoon, sir.
Good afternoon, Sabut. Whatever data you have, you can always get the frequency distribution of it.
Yes, sir.
If
Yes,
you
sir.
have marks,
For all scale, we can convert it into frequency. Yes, sir.
see cross tab, what you get inside the cross tab.
Yes, sir.
What is this 4? What is this 8?
Yes, sir. These are frequencies.
These are all frequencies.
Yes, sir.
So whatever data you have, you can always get the frequencies.
Yes, sir. Especially
Chi-square is used for nominal data.
Nominal data. Yes, sir.
Okay, so it is not right to say that if we have frequency, then you can use chi-square. That's not correct.
Yes, sir.
Chi-square
In
is used when
that place, we can say that we have nominal data. Like
yes,
that.
yes.
Okay, sir.
If it is a scale level, you can still calculate the frequency. If you have income variable, can't you calculate the frequency of it?
Yes, sir. We can find.
But I can use for the income and consumption Pearson's correlation. I need not
Yes,
use
sir.
chi-square there.
Okay, sir. Thank you, sir.
Yes, Ishrat is right. Ishrat is saying chi-square is used when we have category. When you have category, that means you have the nominal data. And to summarize the characteristics of the data, what we need statistics related to measure of central tendency, dispersion, symmetry, that is skewness, kurtosis, that is the pickedness. Nagaraju, why do you say Z square? What is Z square? Nagaraju, what do you mean by Z square? Okay, so let's see, how do we calculate the statistics of the variables? Descriptive statistics of the variables. So again, you go to analyze, descriptive statistics, then again descriptives. Analyze, descriptive statistics, descriptives. And suppose I want descriptives about all these things. And please understand, you can calculate mean, standard deviation, skewness, kurtosis only for the scale data. In options, you can click mean, standard deviation, minimum. If you want variance, you can get the variance. You can click on the kurtosis, skewness. All these statistics will come. That's available in option. Then you say, okay. So get all the basic statistics of your variables. So you can make graphs, you can make tables, you can get descriptive statistics. Okay. Our next item of agenda is how to use Spss for hypothesis testing. And friends, I think I may take some more time, so you have to be careful. You have to cooperate with me, but I want to finish it. So let's go ahead with something interesting. It says attitude is a little thing that makes a big difference. And I hope that this workshop will help you in developing a right attitude towards learning. And it's attitude that really matters. If you have attitude towards learning, you will definitely learn. Nobody can stop you. So let's move ahead with right attitude and with a strong desire to learn the things. And let's go for hypothesis testing. Every hypothesis testing which we do, that may be Parametric test or non-parametric test? अमृत, parametric non-parametric में क्या फर्क है? Anybody else? What is the difference between parametric test and non-parametric test?
In case of non-parametric, nominal scale and ordinal scale data is used.
Okay.
And now for nominal scale, we cannot use parametric test. That is
Right.
what I understand.
That's true. But what is the difference?
In case of parametric test, you need to have parametric values like mean, standard deviation. So
What do you mean by parametric values?
they are the population statistical values.
Nidhi, if you say population value, then it's not a statistics. Statistics comes from sample.
Yes, it is
And whatever
population mean, population standard deviation.
yes.
Yes.
So whatever you get as an estimate from population,
Yes.
that's called parametric.
Parametric. Yes, sir.
So parametric tests are the tests which make certain assumptions about population parameters, like whether they are normally distributed or not, whether you know the mean of the population, variance of the population, like that. If you don't make any assumption about population parameters, then we say it is non-parametric. So it depends. Are you making assumptions about any of the population parameter? If you say yes, parametric. If you say no, non-parametric. Devanjali, normality, of course, the assumption which is made many times, but not necessarily linearity. So forget about linearity. Parametric test category work on mean and its assumption, while non-parametric work on median and mode, right? Yes, sir. As Nidhi is rightly saying that we use non-parametric for nominal and ordinal data. For scale data, we use parametric. Clear? Nidhi, any other assumption? Why should when I should use my parametric test? When I make assumptions, right? When you have the scale data, then I should go for parametric. Anything else? Yes, Nidhi. Anything else?
Yeah. If we have standard values to be compared, I mean, in that case also,
No.
I didn't get your
All
question.
parametric tests are based on certain assumptions, right?
Yeah.
If you have a scale data and those assumptions are not true, then you should use non-parametric.
Yeah, basically, wherever we can have frequencies, I think we can go for non-parametric tests.
No. Don't say that. This is what I was trying to explain to Savud.
Okay.
Frequency to हर variable की frequency हो सकती है.
Okay, no, in case of absence of parametric data, maybe.
For ordinal and nominal, we have no option. We have to use non-parametric.
Non-parametric, yes.
Okay. If you have a scale data and assumptions are true, please understand that. Because parametric models make assumptions about population. So if the assumptions are true on the scale data, then we use parametric. If you have a scale data, assumptions are not true, then you have to go for non-parametric. Yes, Amitabh, if assumptions are fulfilled, then you go for parametric. If assumptions are not, then you have to go for non-parametric. And most of the case, in case of the non-parametric, nominal data, you will find chi-square is used. If you have two categories, there you can make use of binomial distribution, but if you have more than two, then use chi-square. If you have two samples which are unrelated, chi-square, otherwise you can use, McNamara. If you have two classes and more than two classes, then you can use chi-square. If you have more than two samples related, then we can make use of chi-square. Chi-square. If you have two classes, then quotient. So friends, I don't have the time to explain these tests, but this is the list I'm sharing with you for the test, which you can note. For the ordinal data, goodness of fit, KS test. Central tendency test, we use the sign test. And if we have more than one samples which are related, there we use Wilcoxon matched pair. This is compared with paired t-test, which is parametric. So if you are not able to use a paired t-test because of violation of some assumptions, then you can make use of Wilcoxon matched pairs sign rank test. And if it is unrelated, then we go for what is called a Mann-Whitney test. KS test is test of goodness of fit. And if we have more than two samples, related samples, Friedman test, otherwise we use Croxall-Wallis test. For the scale data, variation test, chi-square, and central tendency, Z test or t-test. And if we have two samples, related samples, we use paired t-test or difference of mean or difference of proportion test. And for variation, we use F-test. And if you have more than two samples, then we use analysis of variance. So I think this list covers by and large all kinds of tests for probable conditions for our data. What next? Nothing, but we have to practice something. Male students or female students score more marks in an examination. How to test? What will be my null hypothesis? Mean marks of female, mean marks of male students, both are equal. Alternatively, not equal. And two samples, independent samples. So we have to use difference of mean test, independent sample test. And show you how can we do this. Okay, so Amitabh, what is MOMF, MO? Amitabh, by MO you mean H0 or what? Okay, so I want to check whether the boy student and the girl student are getting same marks in mathematics. U, H, U. Amitabh, I don't understand what you mean by mu u. Nidhi is right if this is your null hypothesis. Anyway, so go to analyze, right? Can you think what option I have to select here? I'm comparing means between boys and girls. So compare means Independent sample t-test. Test variable is score in mathematics, and I'm grouping the students on the basis of gender. Groups are 1 and 2. 1 for male, 2 for female. Then I say okay. I think this will be quite small. So what I do is I copy from here, paste in Word file. I'm just pasting my output in the Word file so that we can see it in a larger way. Right. So first it checked whether we have, the variances equal or not. For that, they are using the F-test. P-value is more than 5%. That means variances are equal. So if you say variances are equal, then forget about this line. Go for it. This is my T. This is my two-side probability value. Null is accepted. That means there is no difference in the marks of mathematics between boys and girls students. That's my conclusion. Okay, let me take another example. Okay, so some workers were sent on training, and we measure their job satisfaction before training and after training. And before training and after training data is measured on a 50-point scale, and this is a scale data which we have. So what should I use here? Paired t-test, yes, because we have before and after related paired. So two samples, in that case, I have to use a paired t-test. So I select that file, satisfaction file. Job satisfaction. Yes, job satisfaction data. So go to analyze, compare means paired sample t-test. Select both the variables before and after. P-value is 0.006, which is less than 5%. Therefore, null is rejected. That means there is a difference in the training level. And before training, the satisfaction level was 27. After training, the satisfaction level was 35.50. Therefore, I can say that training has impacted, in fact, increased the job satisfaction of the workers. That we can say. I think that you can do yourself. Whose anxiety level is normally high, male or female? Yes, Amitabh. So there are two samples, male and female, both are independent. So difference of mean, independent t-test will be used. Do you believe that training can improve the typing speed of the office employees? There you have to use paired t-test. How do we check whether the return of a company is normally distributed or not? Anyone? Suppose I have the share price traded. Yes, I have the Maruti Suzuki share prices. Can any one of you suggest how can I check whether a particular distribution is a normal distribution or not? So I open data and this is in Excel. Amitabh, box plot you can make, that's true, if R is less than 1. Vijay, what do you mean by R is less than 1? When R is less than 1, what is this? Oh, Amrit, दूसरा session शुरू हो गया क्या? They're saying already a new meeting is started.
It's not from our end. They must be participating in some other session.
Okay. So I have the Maruti Suzuki return. Any one of you know how to check? Of course, you can use a histogram, box plot, but any test. Yes, Devanjali, that's graphical. So you can make chart, histogram, Maruti Suzuki with the normal curve. It's a leptokurtic, so it doesn't suggest that distribution is the normal distribution. But to check it, then you have to use KS test, which is a non-parametric test. So go to non-parametric test, legacy dialog. one sample KS test, Martha-Suzuki, test distribution is normal. I repeat again, go to analyze, non-parametric, legacy dialog, one sample KS test, test distribution is normal. And if you see the, yes, Kolmogorov-Simonov test, Amitabh, that's what we are using to check normality. And the probability value is 0. That means distribution is not a normal distribution. So to check normality, you have to use KS test, which is a non-parametric test. Okay, this I skip. I think let me take a small simple problem. A such problem is, what is the impact of the different fertilizers on the production of wheat? That means what we are saying, that the fertilizers is having an impact on the wheat production. And we are administrating a number of fertilizers, and we want to see their impact on wheat production. Say, if I make a graph chart builder, the box plot, but this will not take this because it is defined as a scale variable. So I have to define it as a nominal one, sorry. This is the type of the fertilizer, so I have to define it as nominal data. So fertilizer here, production here. Sorry. So do you think that we have, difference in their production level? Amitabh, fertilizer is a categorical variable, type 1, type 2, type 3. It's not, what should I say, is, scale level variable. The only you can make use of the QQ plot as well. No problem in it. So I go to graphs. Check where that option is available. The one I have to check where that QQ plot option is available to me. I'm not able to see it here. but I'm sure that it's somewhere in the anyway, 5 types of fertilizer, and you want to check whether their production is different or not. What technique I have to use here? What is the technique we have to use here? More than 2 fertilizers, scale level variable, wheat production. What should I use? What should I use? Analysis of variance or Anova is available. Anova is used when we have more than 2 variables. Yes, Ishrat, Anova, Neha, Anova, right. So that's what we are going to apply here. So go to analyze, compare means, one-way Anova. Production is my dependent variable, fertilizers is my vector. Then in options, you can take the mean plot and you can get the result. The significant value is coming to be 0.010, which is less than 5%. Null is rejected, there is a difference. And in graph also, you can see there is a difference. Neha, how do you know which one is different from which one? Is fertilizer different? Fertilizer 1 production is different from 2, different from 3, 4. There's a difference, but which one is different? How do I know? Anybody? There is a difference, but where is that difference? How do we know? Ishrat, Neha, that's what you are saying by looking at the graph, but do we have some statistical tool for that? Yes, we have. And that is what is called post-hoc analysis. If you find that the Anova is giving you significant differences and you want to check where are those differences, for that you have to apply post-hoc. Amitabh, it is HOC, not K. Post-hoc analysis. And I recall my last command, one-way Anova, post-hoc. There are so many one. Normally we use to key one. And then you can see where is the difference. I think let me copy this. So 1 is different from 3. 2 is not different. 3 is different from 1. That's it. The only difference we find is the production of fertilizer 1 and 3. All others are same. And that's what you can conclude. That 3 is effective fertilizer as far as the impact on the fertilizers, impact of the fertilizer on the wheat production is concerned. You can see here fertilizer 3, 1. Okay. I'm sorry I exceeded a lot of time, but hopefully like this, you have a lot of files with you. You can work with those files and become comfortable with Spss. Spss is all menu driven. You have to just search for the appropriate options. So anybody having any questions, most welcome. If they want to talk to me, they can raise their hands. The Avneet will unmute them and you can talk to me directly. Any questions, any doubt, anything? No? Okay. So that's all we want to discuss today in this session. Thank you very much for being with me in this session. And thanks everyone, every participant. And if you want my email, I can share with you my email. It's guptacp@gmail.com. Savu, Amitabh, Nidhi, Avneet, everyone, thanks a lot. And hopefully you will do more work on Spss and become more and more comfortable with Spss. Thank you. Thank you very much.
Thank you so much, sir, for such a wonderful, and you've taken the session in such a.
अमृत तुम बीच में गायब कहाँ हुई थी? अमृत तुम बीच में गायब कहाँ हुई थी?
Sir, I do not have that much of knowledge of statistics, so I was coming in and out. I could answer all your questions. Yeah.
Okay.
Thank you so much. I would like to call Professor Himani to give away a formal vote of thanks.
Thank you, Avneet ma'am. Am I audible?
Yes.
Yes, you are.
Yeah, thank you, sir. Good afternoon to one and all. I am Professor Himani Shukla, member of IQAC of the college, consider my privilege to propose the vote of thanks. I express my sincere gratitude to the resource person, Dr. C.P. Gupta, for this wonderful session on SPSS. It was very resourceful and explained in a very radiant manner, making it easy for each one of us to understand. Thank you, sir. It has always been a pleasure to listen to your sessions.
Thank you.
Thank you, sir. Sincere thanks to our kind management for providing us with the necessary approval and support from time to time. To our principal, Dr. Sridhara Shetty, for being the guiding force in all our strive. Workshop would not have been possible without the guidance of our Vice Principal, Dr. Liji Santosh ma'am, who is also our IQAC coordinator, and Vice Principal, Assistant Professor Sandesha Shetty. The organizing and the technical team for providing with all the necessary support required for the event. I am thankful to all the coordinators, teaching and non-teaching staff of the college for providing their support. Last but not the least, thank you all dear participants for joining us for this workshop. We look forward to meet you again for the next sessions. Thank you once again. Thank you one and all. Thank you, sir.
Thank you.
Thank you, Gupta sir.